Hello, in this video we're going to look at the areas of rectangles programming problem from your textbook, and we're going to look at two different ways that we can solve this problem. The programming problem tells us that the area of a rectangle is the rectangle's length times its width. Write a program that asks for the length and the width of two rectangles. The program should tell the user which rectangle has the greater area or if the areas are the same. So let's just start by writing in pseudocode. Let's just write out the steps that the program is going to have to perform. So first, we're going to ask the user to input the length and width of, let's just call it rectangle 1. We're going to ask the user to input the length and width of, call it rectangle 2. So that's the extent of the input part of the program. So the processing will start by calculating the area of rectangle 1, and then we will calculate the area of rectangle 2. And at that point in the program we'll have the areas of both rectangles, and we can then compare them to see which is greater. Now when we compare the areas of these two rectangles to see which is greater, we can be sure that there will be one of three possible outcomes. Either rectangle 1 will have the greatest area, or rectangle 2 will have the greatest area, or they will both have the same area. So it's going to be one of those three possible outcomes. Now to determine which of these is true, one approach will be to use an if-elif statement in our Python code. And that's the first approach that we're going to look at, and that's, in my opinion, that is the simplest approach. So what we want to do at this point in the program is determine whether, let's call it area 1. This is going to be the area of rectangle 1. So if area 1 is greater than area 2, if that's true, then we know that rectangle 1 has the greatest area. Else, if area 2 is greater than area 1, in other words, if the area of rectangle 2 is greater than the area of rectangle 1, if that's true, we know that rectangle 2 has the greatest area. Now, if neither of these Boolean expressions is true, okay, if area 1 is not greater than area 2, and if area 2 is not greater than area 1, well, we know that the third outcome is that both rectangles have the same area. So we'll just have an else clause. We'll display a message: both rectangles have the same area. So this is a fairly good write-up of the pseudocode for the first approach at solving this problem. Now let's switch over to the Python editor and look at some actual Python code. So here we have a program, and the first thing that we do is get the dimensions of rectangle 1. We prompt the user to enter the length of rectangle 1, and that is assigned to the length 1 variable. Next, we prompt the user for the width of rectangle 1, and that gets assigned to the width 1 variable. Next, we're going to do the same thing for rectangle 2. We prompt the user to enter the length of rectangle 2, and that gets assigned to length 2. Then we prompt the user for the width of rectangle 2, and that gets assigned to width 2. So at this point, we've got all of the dimensions of the two rectangles. Now we're ready to calculate the areas of the rectangles. So here in this statement, we say area 1 equal length 1 times width 1. And then we say area 2 equal length 2 times width 2. So after these statements have executed, area 1 will contain the area of rectangle 1. Area 2 will contain the area of rectangle 2. Next, we can determine which of the rectangles has the greater area. And we're going to use, as I mentioned, we're going to use an if-elif statement. Now, you can refer to your textbook for the exact syntax of this statement, but basically the way that it works is we say if this expression is true, perform this block of code, else if this expression is true, perform this block of code, and so forth. And then we have a final else clause that executes if none of the Boolean expressions are true. And I should note that the syntax in Python, in my pseudocode, and when I'm describing this, I say if, and then I say else if, but it's in Python, it's not actually written as else if, it's written as elif, one word. But you can think of that as meaning else if, but the correct word in Python syntax is elif. Just keep that in mind. So the way that this particular statement is constructed, we test to see if area 1 is greater than area 2. And if that is the case, we print a message indicating that rectangle 1 has the greater area. If area 2 is greater than area 1, we print a message indicating that rectangle 2 has the greater area. If neither of those expressions are true, then we know that both rectangles have the same area, so the else clause takes over, and we print this message, both have the same area. Okay, so that's pretty much the program using the if-elif approach. So let's run this and try it out with some values. Okay, I'm going to enter 10 and 20. Okay, that's the length and width of rectangle 1. And for rectangle 2, I'm going to say 100 and 200. So rectangle 2 should be reported as having the greater area. And that's exactly what happens. So let's try it again with some different data. This time, it's going to be 100 and 200 for rectangle 1, 10 and 20 for rectangle 2. And this time, it should tell us that rectangle 1 has the greater area. And that's what happened. So far, so good. Let's run it again, and this time 10 and 20 and 10 and 20. This time it should tell us that both have the same area. Okay, and that's what happened. So, so from these three sets of data, it looks like this program is working. Okay, well, let's look at another approach for solving this problem. Okay, so this program uses a different type of a decision structure instead of an if-elif statement. In this program, we're using nested if-else statements. We actually have an if-else statement that is nested inside the else clause of another if-else statement. So let's go to the beginning, and you can see that the program starts out exactly the same way as the previous program. We get the dimensions of rectangle 1. We have the same variables. We get the dimensions of rectangle 2, have the same variables. And then we calculate the areas of the two rectangles. Area 1 will be assigned the area of rectangle 1. Area 2 will be assigned the area of rectangle 2. So up until this point in the program, everything is the same. Here we have our nested if-else statements. So let's just see if we can follow along the logic. If area 1 is greater than area 2, if that's true, we're going to print this message saying that rectangle 1 has the greater area. But if that's not true, we have an else clause, else. And then inside the else clause, we have another if-else statement. If area 2 is greater than area 1, Well, if that's true, then we know that rectangle 2 has the greater area, so we print this message. But if that's false, we let the else clause take over, and we know that both rectangles have the same area, so we print this message saying both have the same area. So a different approach, but really pretty much the same logic. Well, let's run this program with some test data. Okay, I'm going to enter 10 and 20 for rectangle 1, 100 and 200 for rectangle 2. We should see that rectangle 2 has the greater area, and it does. Okay, well, let's run the program again with the reverse numbers, 100 and 200 for rectangle 1, 10 and 20 for rectangle 2. Now we should see that rectangle 1 has the greater area, and that's what we get. Okay, let's run the program again. 10 and 20, 10 and 20. This time we should see that both rectangles have the same area. And that's what we get. So two different approaches, but really the same logic in both programs.